Good morning. Happy Friday, everyone. I hope you've all been having a great week and are looking forward to the weekend. We have finished with the MVP that we had with the ecosystem project from chapter 1, which means that we can move on to chapter 2 today, which is super exciting because that's new stuff. Good, Miguel, good morning. So, how are you all doing today? I hope that you have had a great week. I need a coaster for this mug. Got myself some Earl Grey tea this morning to help wake up. All right, so the plan today is to work on example 2.2, which is forces. Forces, like in this book, and so I guess also in case you haven't seen the Nature of Code book, you can go to natureofcode.com. It is a free book that you can read online, or you can purchase it. I actually have a physical copy of the book here. I really do like this book. It both looks great and the content of it seems to be really good too. And if you've seen the Coding Train YouTube channel, that is the author of the book, Daniel Schiffman. So chapter 2 is about forces. And we're beginning it off with like forces of gravity, forces of wind. The next section will be friction, but that'll probably be Monday. So what we're going to work on here is the idea that we're going to create a bunch of balls. They're going to have different masses, and that's going to be represented by the size. And then we're going to allow gravity and wind to be the two forces that work on them. And so as we can see, if we reset, they bounce. We're not adding friction in, so they bounce equally high back up as when they started down, but then the wind also pushes them to the right. When they hit the end wall, they'll of course bounce backwards, but the wind will again push them back to the right again. So we'll just sort of get this wind tunnel effect. And of course, the different sizes makes it pretty interesting to see. Now the book is written in processing. All the examples are in processing. And online, there's examples for P5.js, which is the JavaScript version of processing. But we're instead going to be using Rust and GGEZ. Rust the language and GGEZ the game engine. I would say that GGEZ is trying to sort of kind of, if you squint a little bit, be kind of like processing, only in so much that the game engine that it is based on, Love2D from Lua, is what had it start from replicating processing. But of course, all of those have become their own things these days, which is why it's sort of fun to go through, learn Rust, make sure we're learn Rust and do it by making cool things like this. It's still hot, too hot to drink. Other fun things, Rust just came out with an update, I think yesterday. And I was looking through this morning about what they updated. I think there's only going to be one thing that we really care about. But okay, so 1.38 released. And the thing that we're going to care about the most, we don't have to do anything about it, is this pipelined compilation. So particularly, Rust doesn't need to compile everything now in order to start going. Apparently, it only needs to get the metadata to begin. I guess like to begin linting. I'm not sure like if it, because it would need to compile it fully to like run your code, I would almost imagine. So I guess I'm not fully like certain how exactly this speeds up everything, but it claims to have a 10 to 20% compilation increase in speed, which I am all for that. Besides that, linting of incorrect uses of memory uninitialized 0. I've never used that before. They've added deprecated macros in case we're creating libraries and we need to mark a method as deprecated. This one is interesting. There is now the ability to print out the name of the type, which of course is mostly, well, I think is going to be only useful in generics. So we can have a generic function, and all it does is print out this standard any type name, and then we get the type printed out. A bunch of library changes. I think the biggest one that's affected us in the past, and maybe we'll be able to take advantage of it today, is this duration as sex F32. Because we were trying to get that delta time, and GGEZ gives you delta time as a duration, and previously we weren't able to get it as sex F32, but now we can. And I did update like my Rust up this morning, so we actually have all of these available to us. And that's pretty much it for us. So let's see about getting started here. Brand new project. We're gonna start from scratch essentially. We're also going to use our what do we have? We created a gmain here. I think. Oh right. So like, what are we calling this? I think the problem is we have to look here and the name. So grab that, use everything in there, which I can't find because we haven't created the lib yet. So use, oh, we're gonna have to add GGEZ in. Okay, so the name of the thing. This is gonna be I'm not sure exactly where the name it gets used. I wonder if it like will print it out at some point in time. So we expect that, then new game. This game is going to come from our library. And then that should be pretty much it. So we're going to save there. And let's now open up lib.rs. So we don't have a mod to open up yet. We will. I think this is just a reminder of like that's how it works. We also realized that 0.2 is not only the best one since then, because well, we need 0.2 for a lot of things, but vector 2 is a better one for actually just like storing everything in, because we can use the math with it. Oh, we need rand too, so let's pull that in. That should make you happier here. Oh, this that tab needs to happen, so we should update that. So here's our glib. I'm thinking we don't really need those two and that. We can add a snippet for the use mod. We need one more. Also, so we have window height. I kind of want to change this to just grab this as the, what is it called? Arena size. And then store that as a tuple in here. Which means we need to update that too. Okay, so that's storing you. We're also trying to store range, a random number generator, but we want this to be a mutable version of it. So can I store that here? Oh, that probably will be like a lifetime problem, won't it? So I could store the real one here and then just pass mutable references to it from everywhere else. But let's put in, so we have rand create. There. So that will store us our RNG. Okay, I think we're good there. Expected type found function. Oh wait, are you a function? You are just a type thread RNG. Yeah, okay, so now it's just never used. So I need copy you. Okay, I think we're ready to like get going here. Still a little hot, but more drinkable now. So what do we need? we first need, we're going to need to create the ball structure, and we want to just like put one onto the screen. So that's going to be a new file here. I'm going to just call it ball. I don't think I need anything else in here. So let's just do ball.rs, which means we do now need to do the mod. So mod ball. It'll just be like mod ball. All right, so what do we need in here? So we know we need a location, which means a location is also going to be, we're going to have it store the location as a vector too. So GGEZ and algebra vector 2 here. And that's an F32. We also know we need a velocity. Velocity, which is also a vector 2. So location, velocity, acceleration. And that's what we were dealing with before. We also now, we're going to have forces that apply to this, and the forces are also going to be sort of manipulated by the mass. So we need the mass of this, which is going to be an F32. Well, we probably want color, which is going to be a color. Before I forget, I'll just turn on that so you can highlight any lines of text that you want. Let's see. So we have a color, we have our mass, acceleration, velocity, and location. What else do we care about here? I'm not completely sure. I think that'll be it. So now we'll do an implement on a ball. So we'll first have a public function new. This will take in the arena location, so we can start it with that upper left side. Now, do I care about like, because when I initialize it, I could just take in the location, or I could just have it choose the location. I'm thinking in this case that the ball shouldn't really care where it starts. Like, we'll tell it where it starts. So we'll just grab a location, which we know is going to be a vector 2 of F32. What's next here? So we know we have the location. Our velocity and acceleration are going to be zeroed out to begin with. We're going to have a mass, probably a randomized mass. But this could also be just like sort of randomly like generated outside of us. So this will be an F32. And our color, we should probably choose like the ball should just randomly choose a color. So we'll take in a random number generator, which is a mutable reference to nope, not that one. That one. Red range. This will also return a new ball. So I think everything can just sort of be part of this. Just immediate implicit return of ball. We'll give the location, velocity. Oh, so velocity is actually going to have to be a vector2 like that. And acceleration is also going to be a vector2. Our mass will just be passed into here, and then our color. So I'm thinking we'll just do the from RBG. So this will be color from RBG. Now, the one online has slightly see-through. That might actually be more interesting. So we can do from RBGA. So red is going to be, so it's a U8, but I can now do RNG dot, what is it? Gen range. So this will be from 0 through 255. And their alpha, I'm thinking maybe we'll just set this to be 100. And this should give us a brand new ball that's just going to be wherever we tell it to go. To display this, we'll need our draw function. So maybe like render might be a better name for this, because it's creating the mesh, or maybe like create mesh. I'm not sure, but we'll need under graphics. We'll need mesh and mesh builder. Okay, so pub function, what do I want to call this? Like, also I'm a little concerned. Let me make sure that Twitch chat is working. Oh no, it is, because I got the bot came in, so. It's happened in the past where Twitch chat was frozen on my my screen over here, and then you all were chatting and I couldn't see it at all. So I just sort of talked to myself the entire stream. Okay, so this is gonna be, I'm gonna be creating the mesh that's gonna be drawn out to the screen. So it's not necessarily rendered. I think that happens in the main library. But I guess create the mesh. Create mesh. We're gonna take a mutable self here. We also know we're gonna need context. And this can be a mutable context. Oh, game result. We need a game result too. So we're going to return a game result that has a mesh inside. So these are balls, just spheres. So that's going to be, or circles, I guess. That's going to be a lot easier to create than anything else, because we'll just be able to do create new circle or return a. We don't have to do the game result ourselves. It's actually just going to be a mesh builder new, and from that we're going to do dot circle. So draw mode. So that is actually going to be under graphics. Draw mode fill. Our point. So this is where is it going to be? Well, that's going to be the location. So self.location, but we also need to convert this into a point. So as a point 2. Our radius. So I'm thinking right now we're going to follow what the book does and just do self.mass, and it'll be a 1-to-1 ratio for the radius. Our tolerance, we want these to actually be circles, so 0.1, and our color. So we're gonna draw our circle, and then I think it's just build, which takes in a context. Oh, so we can't do an as here. Oh, right, we have to do a from. So we have to do point 2 from self dot location. Right, okay, so that's perfect. This now creates the mesh from us. We can now come back to library. We have to now create the circles. We're not going to delete any of them. So I think we can do all the logic in here, because this is going to be a fairly basic one. So we're going to want our, I guess, like balls. We're going to be a vec of ball. So I'm thinking we're eventually going to create a whole bunch of them. Let's only create one right now, but I'm going to we don't really care in 0.1. So in here we want to create a new ball and push that in. So it's going to be balls.push, and we're going to put in ball new. Okay, so our location. So we do need a vector 2. Okay, so where do we want it? We know we want it just a little bit over to the right. So maybe like, let's just do 50.0 to the right and like 50.0 down. Mass, we can have this, we can actually use our random number generator for this. So we can say RNG gen range from 1.0, so absolutely tiny, to maybe 25.0. And then the random number generator. So that is going to be a mutable reference to RNG. I always forget to make you mutable. I don't even have to look at the error. I know what it is. Okay, so we're able to move forward again. And so now we have our event handler here. So we don't really care about update right at this point. We're going to just draw. I don't know why I have so many. That must be inside of here. Yeah, look at that. I don't need all that space. So in draw, we have to get the mesh from this. So we're gonna say, and then we're gonna have to draw it. So let's call this, we also have to loop through this and do this. And do that inside of the loop for all the balls. So for ball in self.balls. All right, so let's get the mesh. We need to pass it mutable reference to the context, and I think that's pretty much it. We also have to question mark this to actually get the real thing out. Cannot borrow ball as mutable, so we need you to be, I think, a mutable reference. Yeah. Then we're going to draw mesh. So what is that? That is, I think it's just GG easy. Oh, it's graphics draw. So we're going to draw, pass it the context. We pass it a reference to the mutable, so the mesh. And we also pass it a tuple of parameters. So in this case, a location. Don't really need anything in here. Just that, and then a comma, because there's potentially more stuff you can put in here, like a color to override. We don't need that. And I think just a question mark to handle the result that it puts out. I think that's it. I have 2 errors though. Oh, expected. Okay, so my error is in here and here. All right, let's. That was a lot of typing. Let's see if it works. Let's also see if this compile time is any better. I mean, I didn't really time it before, so I can't tell for certain. I mean, the computer fans still spin up like normal. All right, and we have our ball right here, just sort of hanging out, ready to move and fall down, do its thing. You know what would be really nice is to get this to take half the screen size and then a lot more down too. Although I don't know how good that would be in this specific case. Maybe wider would be good. I'd have to look up how to set the window size when we're sort of initializing it and setting up. Okay, so we have our ball. Next up, let's make it just let's make the force of gravity take effect to it, and that will be just it. And I should commit you all. So ball showing up on screen. All right, so force of gravity. Well, gravity is going to be a constant, so that's something that we should store inside of our game structure. And then we want to apply a force. So I'm just sort of going to use all these functions here. So we'll just have gravity. This is going to be a vector 2 of type F32. So we know that gravity doesn't really move us to the left or right. It's always just peer down. So that's going to be 0.0 for the x, and arbitrarily, let's just choose 10.0 for the y. This does mean we're going to need the delta time too. So in update, we need to get the delta time, which is part of timer. Okay, so let delta time equals, this thing is timer. Get the time between the start of the last frame and the current one. In other words, the length of the last frame. So I think that's good. And that gives us a duration. And I want to, as seconds F32, you need to not be underscored anymore. All right, so that gives us delta time. No more errors because this is unstable now. So once we have this delta time, we now need to apply the force of gravity to the ball. So that means another loop. So we're going to apply the force of self.gravity. Once we apply gravity, then that's the only force we have right now. Then we need to tell the ball to, I guess, like move. Or maybe just like update. We're probably going to need to pass in, oh, do we need context? I don't know if we need to pass into context at all, because we're just going to tell it to like change its location. we do need to give it the delta time. And I think that, well, okay. We also need to tell it what the arena size is, so it could bounce off of the walls. And do I care to do that here? I think I'll just have the ball take care of that for us. So I'll also pass in the arena size. Now, once update happens, then the location will just automatically sort of update as it just goes down and up, down and up, down and up. So I think we're good now. Let's go ahead and write those functions. So it's complaining that we're missing no method apply force. And it's gonna be on ball. All right, what did we say we're gonna take in? Just the force, which we know is going to be a vector 2 of F32. We're not going to return anything. So the apply force is actually going to be part of acceleration here. So this is a fun part. Last night I was going over this when I was choosing what to do today, and also like reading up so I could do it. We're going to do a little bit of algebraic math here. So what is it? Force force m equals, I forget the name of the actual, mass equals acceleration times force. Is that, I'm going to load this up really quickly. It's the good old force equals mass times acceleration. So mass times acceleration. But of course, we don't care about getting, like, we know what force is because it's being handed into us, and we know what mass is, it's right here. What we don't know is what acceleration is. And so we have to deal with that. And in algebra, because this is on the right-hand side here, and either side is equal to each other, I divide this right-hand side by acceleration. And that will make acceleration go away over here and appear over here. So acceleration, and there. We have force divided by acceleration equals mass. Oh wait, no, it's the opposite way. I want to divide mass on this side. So you become mass. There. Force divided by mass equals acceleration. So when I want to calculate what we need to add in here, we're just going to take this force, divide it by the mass. The other thing is that all the forces acting together, so when we eventually have multiple forces, we're going to just add it to acceleration. So the first thing we're going to do in our so we need, well, I guess that will be the last thing we do. So let's just do this apply force. We're going to say self.acceleration plus, now we need to take our force and divide it by self.mass. I forgot to bring in self. All right, so that should apply the force and make gravity be affected by it. Next up is going to be our update function. No method name update. All right, what are we passing in an update? Delta time and the arena size. And again, we're not going to return anything here. We're just going to update ourselves. So we now have the acceleration, so we need to add the acceleration to velocity, but we need to first multiply the acceleration by our delta time. So I think we only have to do that once. I guess like the question is, do I multiply it now by the delta time, or do I do it when I update the location? I'm thinking when I update the location. So we're going to self.velocity plus self.acceleration. Then we're going to update the location. Plus, and here's where we're going to say self.velocity times delta time. Sort of like slow that down a bunch. That should just make it fall down. And then the last one is we need a function to self.bounce. I think like just bounce maybe. And we need to pass in the arena size. We're not going to return anything either. This is just going to mutate our state up here. So what we care about is as it comes down, the ball is going to come down. We're going to hit the bottom. So if self.location.y, so if that is greater than the arena size, so it's x and y, so .1. Then what happens? We want to reverse. We want to set the location so it doesn't like get that weird get caught in a wall thing. So self.location.y. We're going to set that to the arena size .1. And we're also going to reverse the y velocity. So self dot velocity dot y multiplied by -1. That should make it bounce off the bottom. I'm not going to worry about the right hand side at this point in time because we're not adding in a wind yet. We still have an error. Cannot multiply integer to F32. All right, so this needs to be .0. All right. No errors. Let's see if this is working. It does work. That was really fast. So I don't know if you saw this. It also just like reduced down in height. So that's, I think the gravity is too strong. It's like holding it down. Let's make gravity like, I don't know, 1, really, really small. So that's interesting. It like bounces a little bit and then it eventually stops. I don't have any friction on this, so it shouldn't be just like stopping at the bottom. I'm wondering if I need to apply the delta time earlier in the process. So what if I apply the force of gravity and hand it the delta time here? And then I don't need to necessarily hand it at update. It's already been applied. So we're not going to take in delta time here. We're going to take it right here. Okay, so acceleration equals self-acceleration plus force divided by mass. And this entire thing, I'm going to then multiply by delta time. There is a bounce effect. I mean, there is so forced to accelerate upwards. Oh, you know what? I think I realize what's happening now. We're not resetting our acceleration. So there is a bounce effect because as soon as I'm hitting the bounce, it is reversing the velocity, which should make it bounce upwards again. I think I know what, we don't need u anymore. We're just going to do self.velocity. You know, we need to reset acceleration because it's going to be like whatever it was before, which in this case is gravity. So it's just going to get stronger and stronger and stronger and eventually hold it to the ground. So I probably didn't, probably things were fine. Hold on, I want to update. I want to bring this back, except not that far. I want to keep delta time here. So in lib, yeah, we're going to keep you a small gravity. And in ball at the end of update, we need to now set our acceleration. So after we do all this stuff, we need to now say self.acceleration equals acceleration times 0.0 to reset it completely. Yeah, there we go. So now we get that bounce that's even going down and up because there's no friction. So it never slows down. Yeah, and so there is no, even though there's no force to accelerate it upwards, is it getting higher? It feels like it's bouncing higher. Or wait, now it's lower. Sometimes it's like really high and sometimes it's low. I wonder if that's the delta time affecting this here. That might be. That's actually really interesting. It's a little fascinating to see the delta time be affected like this. Let's move you over to the left, you over to the left so we can see it. Okay, so I want you to be more even, like predictable, not getting stronger. So we're grabbing that. I do wonder if like this delta time is the appropriate place to put it here. I'm thinking not. Let's try that other experiment I was going to try, which was putting the delta time here and apply force. And then we go away. So acceleration, self-acceleration plus force divided by mass. And then we're going to multiply this entire thing by delta time. Maybe with a higher frame rate, you get more reliable visualization. It's possible. It's also possible that my frame rate is like vastly changing. Or maybe I'm getting some kind of like floating point number errors, because that happens a lot with floating point numbers. Also, maybe this delta time like duration as F32 isn't as accurate as we were getting before. That's always a possibility too. So if I do this, let's go back to live. We're not going to pass in delta time here. We're instead going to pass it in here. So right here. So far, this is looking a lot more consistent. Okay, just as soon as I say that, then suddenly it decides to jump higher than it was previously. Of course. See, I'm not exactly sure why this is bouncing suddenly like higher than it. Well, then it's right back to where it was. I can only imagine that this is due to the delta time being slightly different each frame. But yeah, so like I bet if I did have a higher frame rate, oh, you know what? I could probably cap the delta time. What is 60 frames per second. I don't really know. I don't really know how I want to print out delta time. I want to debug that. Just to see what size number this is. I know it should be really small. Yeah, so take a look at this number. It's absolutely tiny, which is exactly what we want here, but it is vastly different. So it's changing by a huge amount. So I want to see, let's see, delta time cap to 60 frames per second. I don't remember exactly. Oh yeah, so like I might have to look up later on to find the what exactly the math for this is. Specifically, I need a cap of this. So 60 frames per second. This is the time in. So as seconds, how many seconds it took. So this literally be like 0.6, like 0.06. I may have to spend more time thinking about like what exactly the cap for this number would be, because we see that there's something like 0.000 number. I want to make sure it's like a little bit more uniform. So when it drops below 60 frames per second, we'll just take whatever the delta time is. If it is above 60 frames per second, we slow it down. So what would that be? We need times 60 divided by 60. Is that literally just 1 divided by 60? And then if we compare that to this, whichever is higher. So let delta time cap equals, so would it be like 1.0 divided by 60.0? And then we would have if delta time is greater than delta time cap, then delta time, so this will need to be mutable now. Set delta time to delta time cap. Otherwise, leave it alone. See if that looks appropriate now. It's still changing wildly, so I don't think my cap is like too high for this. So I'm not exactly sure what the best way to do this is. I'll have to look this up later. I'm gonna remove that for right now. Katali, good morning. Hello. All right. So we have our delta time. I'm just going to leave the delta time in here. Even though it's not really doing anything for us, it allows us to use full numbers for things like gravity, which otherwise I have to do something like 0.00001, which is not fun and easy to work with. So moving down, let's actually, the last ball was way too small. So let's make our ball size, we're passing in the mass here. Let's move that. Here's our mass. Let's make this like a minimum of 5 and a maximum of like 50. And I think that should work. And then we also want a gentle wind applying to the right. So let's do that too. So we'll have a wind. There's also a vector 2. So this one isn't pointing down, it's rather pointing to the right. So that's going to be, so if gravity is decently strong already at 1, so let's make the wind at like less than half that, like 0.25. And then we just want to apply the force of self.wind and delta time. And then we'll update the ball. So we should now, for free, get the balls moving to the right. I don't think we have the bounce on yet off the right-hand side, so there is that. That is too dark. It did, I mean, it looks good. Let's implement bounce, and I also want to make sure that the color has a minimum of like 100 for each of these. 255 is white, I believe. So there's that, and then our bounce. Okay, so this is off the bottom. Let's also do if self.location.x is greater than arena size.0. All right, so that will just reverse the x velocity and send it backwards. All right, so now it's a little bit brighter, so that's a little bit easier to see. So this is pretty cool. It's basically one of the balls that's doing exactly what we want it to do. Can you do minus velocity.x instead of multiplying it by -1? You know what? That's a good question. Let's try it. Also, I want to take that debug off. That's kind of annoying now. All right, so self.velocity.x equals like the opposite of self.velocity.x. And let's just, for good measure, try it there too. to save you. Yeah, that seems to work. So that's perfect. You don't know why, but it is quite satisfying to watch it bounce around. I think it's also really satisfying because it's very smooth. Like there's no jagged movements except when it bounces off the wall. But that's exactly what we would expect because we see that in our daily life all the time. So we have a single bouncing ball. I think it's a decent. I could make the color even brighter, I bet. By just making this, let's just make it like 200. Also, I think it can be even bigger. So our mass here, as small as, let's say 10 is the smallest one, maybe 100 is the largest. So notice how like slow this is. I think we could also make the wind less effective, like very, very low wind. So this is like 0. I don't know, 1. And I think now we can add in a whole bunch of these balls. So let's do like 25. There's a problem with my bounces. What's the problem with my bounce? Let me go to the appropriate thing and you can highlight. Also, it does not like, I'm not even, there's no like collision detection except with the bottom wall and the right wall. Is that, that is slowing down a lot. Because like gravity shouldn't have been affected. You have to set the ball's position of the ball to self that arena size plus or minus the ball's radius. Oh, well, so like you see how I'm having it like bounce halfway through, so it's like the center. So it should be fine. I guess like I can make it more visually appealing by making it bounce off of the bottom here. So we could do that. So if self.position.y, so if the center of the ball right here minus self.mass, so if that is greater than arena size there, then self.location of y equals arena size of 1 minus self.mass. And then we reverse the velocity. And then the other side, if y, and then right here, minus, so minus self.mass. If that's greater than arena size, set the location to arena size at 0 minus self.mass, and then reverse. So that should do that. The maybe to help not do as many calculations here, let's also start. We only need to do the bounce off the left, off the bottom, if we're heading down. So if self.velocity dot y is greater than 0.0 and this. So if self.velocity.x is greater than 0.0, then we'll check the right. Otherwise, we're not going to check the bounce. All right, let's see if that improves our performance any. Ooh, it doesn't like that at all. Oh, I forgot the and. I mean, it looks like a little tiny bit, but not very much. These are also bigger. I might be able to increase the gravity and then it'll be better, or I could just decrease the number of balls that we have. I could also try compiling this for production and seeing whether or not the, ooh, that's not good. It goes fully off and then resets the way we want. So I've reversed, I messed up how this works. So if you don't need the minus on if. So if self.velocity.y is greater than that, and self.location.y. So that's like self.location.y is the center. Oh, plus. So I want plus here. Which means I also want plus here. And let's make this like only 10 balls. Little bit better performance now. And now it's bouncing properly off the bottom, so we're probably going to get bouncing off the right properly too. I'm thinking we also want to increase the gravity just a little bit. So we can make you like 5. And wind can probably be the same. Wind, I think, maybe is a little bit too weak now compared to the gravity, but it's looking good. So maybe when I just increase the size, it looks like it's a performance problem, but in reality, it's just they're too. The mass is too big. So I need to. I think the gravity looks good now. Let's make this like a 1 for wind. And the other thing that I want to do is look up how to change oh, come on. Don't let me. Okay, fine. Okay, so when I create a new window and I set this up, I want to set the size of the window. I don't think this has it here. Is it on context? Also, why isn't there a search on this page? Yeah, okay, so there's nothing here for the size of that. I bet it's on graphics, but maybe also context. Sets the window mode setting. Context builder sets the window mode. When sets the window setup settings. Create a new canvas with the current window. Okay, so I think in main we have it where it's creating the canvas. Okay, so we have this context builder here. I bet in context builder, can we set that up? Here it is. Window setup. Sets the window. Wait. Okay, so we have to give it a window mode. A builder structure containing window settings that can be set at runtime and changed with graphics set mode. Oh, look at this. So we can set all these things. Is there like a new on this? No, but there is functions for setting like dimensions, maximized, resizable. That's interesting. Right now, resizable wouldn't work because we're keeping the arena size sort of like set in it. So we might want to change that and like re-grab that every single frame then. So context builder. Dot window mode and then hand it the window mode. Okay. So I'm thinking here. Okay, so let window mode equals, we need, is that off of graphics? Struct GG easy conf window mode. Maybe we'll just grab it off of the base. So window mode. So I have to just like get the base of it because there's no new. I think I do. So it's just like that. Missing field, borderless, full screen type, height, and 7 other fields in initializer. Okay, so we need to set all of these now. So width. What are you gonna be? Whatever the width of, like, maybe my screen here. I'm not actually sure what I have. Let's try 1920. And what are you? You're an F32. Maybe like 1080. Gun games. You assume because I'm not on Windows, this is being rendered with OpenGL. I think it is. I don't remember off like the back end what it's using. 800 by 800. Oh, and then full screen true. Ooh, we could do that. I don't almost want it to like fill up this side here. So like, because I have that empty space. It's like whatever half of this is, that might be something like, I think it's 1920. Can I actually look at my display and see what I am? Okay, so I'm at 1920 by 1080. So 1920 divided by 2 is, what is that, 9? Well, but it's, okay, probably 800 is right for width. And then height, so 1080 divided by half. I mean, I'll just try 800 by 800, and then we'll just like adjust from there. All right, what else do we need here? I'm gonna move this to the right temporarily. No, don't do that. There we go. Now I can just reference this. So we have width and height. We have, so maximized, we're gonna start this with false. Full screen type windowed. This is Ubuntu 19. Yes, it is. Resizable, I want that to be true probably. Like this seems, can I just copy and paste you? Yes, I can. Perfect. So we'll just start with the defaults here. Maybe we'll make you like 900. Maximized, false, full screen type. Okay, so we need to pull in you. It's not in the root. Where do you come from? GZ-conf. All right, well, I might as well, okay, GZ, conf, full screen type. I'm missing a semicolon. And then here, before build, we're gonna have dot window, is it mode? I think window mode, and then the window mode. I think that's what it is. Pop! OS is only slightly different. Pop! OS is based on Ubuntu, isn't it? All right, so let's just try running this, see what happens. Hey, this is a little bit better. So can I can't do anything yet, but it looks a little bit better for us. We can probably go up to like 1,000 or so, maybe like 950. Oh, it's System 76's version. I thought about buying a System 76 notebook, but I ended up going with the Dell instead. So with you, okay, we can be a little bit wider. Let's be 900 by 1000. Maximize false, borderless, resizable true. And I don't have a max height. Set maximized. Okay, well, let's try this. We'll try that. It may just like start off full screen. I don't know. It's an experiment. Oh, it does. It's actually bigger than a screen. That's really interesting. All right. So that's cool in a not good looking way. So probably not maximized true. Let's try this as false. Let's make this more like 950 down, and like maybe 900 down and 950 across. With resizable true, I bet that will be better. That's like almost exactly what I want. It's a little bit too wide now. But I can resize this so I can go like that. But when I do that, like all the circles get a little bit too wide. You have a Lemur, which isn't so great, and an Oryx Pro. Once the issues with NVIDIA drivers were cleared up after the release of 1000 series. Oh, okay, so they're better now than they used to be. That's actually really good to know. And I can also increase down here with the size. Oh, that's interesting. If I look at that, the arena size is staying the same, like even if I scrunch it. So I thought I was going to have to change that. Now, they're getting scrunched up when I do that, or like it's warping the size of the sphere. So we have mass. We're making a circle with draw mode fill. We're setting the self.mass as the size. And we're creating this every frame. I don't know why it'd be doing that. When I scrunch this up, every single frame, it should like redraw that as a circle. Gareth, good morning. I'm doing good. How are you all doing? I did ask at the beginning, but there's more of you now, so let me know how you're all doing. Is it because this is scrunched up and it's doing this, it's creating a circle based upon the size that I create in main? If I set you to be 0.0, will you just know what you're supposed to be? You're alive? Well, I mean, that's a good thing. Maybe I can set the min width to be something like 925 and the min height to be 900. I am not using Rust professionally right now. Thread main panicked. Failed to create input context. Okay, so it really did not like this starting with 0.0. So let's make this like 925. They're all circles now. If I scrunch it up, well, I can't go less. I can go more and wide, but it's still getting that sort of mutating the shape of it, which is not what we want. But I can now do this to it, sort of like move it around. Does GGEZ use 0, 1 coordinates? What do you mean by 0, 1 coordinates? I don't know if I understand. Let's see, full screen type, borderless, resizable. I might need to research into how to make it when we resize it, it doesn't like scrunch this up. Or maybe I need to like, oh, top left, 0, 0, bottom right, 1, 1, normalize. No, they don't. So it's 0, 0, top left, and it's like, for example, right, well, whatever this is. When it started, it was 925 by 900. So that would be 925 width, 900 down would be the bottom right. So it is not normalized to 0, 1. So I can set this to be the entire screen. What if I do full screen type desktop? And we start this maximized. How am I drawing the circles? So in here in ball, I create a mesh, which creates a new circle. I tell it to have a fill draw mode. I give it the location where it's going to be, which is really just an X and Y coordinate. I give it the size and radius that it's going to be. I tell it how many points around it's going to draw. And I also tell it the color. I build that, and then over in library for each of these balls, I get that mesh that I created, and then I draw it to the screen and tell it where to offset it to be, which is no offset. So wherever it claims it wants to be. Let's try doing that. So it'll be full screen. The circles look a little bit off, and the screen is definitely off too. Like, I'm not actually getting the real... The meshes might be creating the distortions, but I don't know enough about the meshes to like be able to cancel it. They're circle-like, they're just not exactly circles. Can I mean, this is better, but it doesn't know what it is. Also, I lost the bar. So that window mode is not what we want. I wonder if I need to set, yeah, maximize does seem to do some weird things. Resizable. You know, do I need to set like the arena size constantly? So here we have under context. Oh, it wouldn't be context, it'd be graphics. So remember, we're able to get the window size. It's like screen coordinates. Returns a rectangle defining the coordinate system of the screen. So we could get that maybe. Set drawable size sets the window size resolution to the specified width and height. So like we could set the window mode. Yeah, I think you're right. We're gonna have to set the window mode whenever it gets reset, which seems a little bit odd. But maybe it's just like me not being used to game engines. Is this something you have to do in other game engines? So set mode sets the window mode such as size and other properties. And maybe we have to get drawable size. Returns the size of the window's underlying drawable in pixels. So do I want drawable size? And then I set the window size? Okay, so that is normal. Oh, I set drawable size. Returns the size of the window in pixels, including borders, title bar, returns 0 if the window doesn't exist. I don't want that. So I can like set the drawable size. Well, here's maybe a question with this. If I just set drawable size, so GG graphics, let's say I do that. All right, so maximize false. In the main library, in update here, before we do anything else, maybe we'll get delta time. We'll just say, what is it? Graphics, set drawable size to something. So we need context. Let's just set it to something crazy like 100.0 and 100.0. And I need to question mark it. So will this just like scrunch it down, or will this make a square within the window? I don't know. Let's find out. I don't see this like setting the drawable size to like really small. So I don't think that this is working. Also, did I maximize false, borderless false? I think we want this to be windowed again. Resizable true. I mean, so this makes sense. If I resize it, oh, take a look at that. No, it's resetting to me. But as soon as I try to move it, it like goes, oh man, weird things happening. It tries to be larger. Did you consider Nanu instead of GGZ to code the nature of code? If so, what convinced me to use GGEZ? I mean, I didn't really look too hard for other game engines. I chose GGEZ on the recommendation of a friend who used it a little bit. And that's, I mean, also GGEZ claims to be based upon Love 2D, which I used to create some games in the past. And I really like Love 2D. And so therefore I decided to, I mean, that's about as much as my thought process went into it. That's crazy when I like hold this, everything changes and it just zooms off the screen down to the bottom. So this is all like not happy. So this like set drawable size is not what we think it is. Oh, cool. I can't even move this behind something else now. Now there's the set mode, which like sets the window mode. Ooh, wait. Setting the window mode may have side effects, such as clearing the screen or setting the screen coordinates viewpoint to some undefined value. It's recommended to call set screen coordinates after changing the window size to make sure everything is the way you want it. Okay, set screen coordinates. Sets the bounds of the screen viewport. The default coordinate system has 0, 0 at the top left corner, with X increasing to the right and Y increasing down, with the viewport scaled such that one coordinate unit is 1 pixel on the screen. This function lets you change this coordinate system to be whatever you prefer. The rex, X, and Y will define the top left corner of the screen, and the plus is width and height will define the bottom right corner. Oh, interesting. So I give it a rect of like whatever this is. That's cool. I would want to maybe combine that. So here's screen coordinates. Returns a rectangle defining a coordinate system of the screen. Oh, so like that's whatever it was when it was set, probably. So drawable size, I'm guessing, is what I want. Let's try printing out what happens if I get the drawable size. So I'm not going to do you anymore. Let's actually just debug this. Do I have access to graphics here? Yeah. All right, so this is 925 by 900. That's kind of what we expect it to be. And if I change this, it increases in size. So I bet I can create a rectangle from that. So we have this drawable size. So let do that, and we'll let it's like the new screen size. So we need a graphics rect new. So it's going to be the X. So we know that's going to be 0.0. The Y is 0.0. And then the width is going to be drawable size dot 0. And the height is going to be drawable size dot 1. And then we want to now set graphics. What was that thing that we wanted to set? We know it wasn't set drawable size. Set screen coordinates? I think it was set screen coordinates. You return a game result, so that. All right, so no errors. Let's see if this updates the screen size appropriately. So normal circles. Hey, look at that. Oh no. Well, it keeps the circles the same size, but now they're bouncing off of like the wrong thing. So that's not what we wanted. If I move this down like this, I mean, that doesn't help too much, but I mean, it's cool that I'm able to get that. Let's see, is there anything else that I could do to like change the size of this appropriately? So set screen coordinates. I don't think this is what I want it to be. Because this is 0.0 and we're trying to get drawable size. You can debug this. Okay, so it is increasing with this. It's just, I don't think that's exactly what we think it was going to do. Maybe I have to do both set the screen coordinates and set oh, that's like a full mode. I don't want to do that. Oh, maybe I want to do set screen coordinates and set drawable size. So what if I do that? Set screen coordinates. So width is going to be our drawable size dot 0. Okay, let's try this. Oh, I thought I was going to do it for a second, but no, that didn't work either. So I'm able to get like the full screen width, but it's very unhappy with this. So I think I'm gonna just have to cancel out what I'm trying to do. And we'll just keep like the size of what it is. And maybe we'll just make resizable false. Then at least like it's a nice size, and I can move this over into oh, I can't move it to the right. I can move it here. I can work on like the exact sizing that I want, like actually do the math appropriately. But at least it looks a little good, kind of. Let me go ahead and push all these changes on up. All saved. So many balls on the screen. You know, and maybe before I push that up, let's try a lot of balls. Let's see how many I can get on a screen. Let's do like 50. I want to see if this actually lags it, especially if I compile it for production. I don't know if I have time for that. I have to. My stand-up starts at 9, so this is pretty good movement here. I don't think I need to get this ready for production, just to like have it compile properly. But this was the challenge, the example. So with 2.2 from Nature of Code. Now you were suggesting Nanu Vuzuela. I cannot pronounce that word. That's the horn that was used at that oh, I forgot the name of the like what game it was used at. It was like the World Cup, right? I can't remember anymore. But I will take a look and research that and just sort of see if it's something I want to look into. So look to a new game engine. Well, with that, I'm gonna push all these changes up to GitHub. Right, it was popularized at the World Cup South Africa. Ah, okay, that makes sense. So I'll leave you running over here. You get to go over here, and let me go grab that code. So this is on my GitHub at Brooks Builds Nature of Code in Rust. I am currently in the chapter 2, example 2.2, forces acting on many objects. All right, good. I did pause it, even though that is not showing it correctly. Here is a link to the code. Feel free to go take a look at that, fork it down, make any changes. If there's things you'd love to see in any of the projects in that repository, feel free to open an issue or do a pull request. It is not October yet, but Oktoberfest or Hacktoberfest is coming up, which means that if you sign up for DigitalOcean's Hacktoberfest and you make, I think it's 5 pull requests in a month, you can get a free t-shirt that's proclaiming you to be an awesome open source developer. I've gotten a t-shirt last year, so I will be happy to sort of look at those pull requests, discuss them on stream, potentially bring them in. You don't need to get the pull request accepted to get the t-shirt. So I think it's a great thing to sort of like get into open source. With that, I do have to go get ready for work. I'm working from home, which is why I was able to stream so late today. But my stand-up starts in around 10 minutes, so I need to go prepare for that. Without any further ado, I don't have anything else, so I hope you all have a great rest of your day. And my next planned stream is going to be Monday morning at 6:45 a.m. So I'll switch over to this. All right, everybody. Have a great weekend and see you Monday.